All right, AP Computer Science A. This is the Unit 1 multiple choice packet. So I'm going to go over these problems. Hopefully you've tried them all already. Check your answers. I would read that first excerpt from Barron's study guide before trying these in the first place. Okay, so which of the following pairs of declarations will cause an error message? Okay, so you have a double and you put a double in it. No problem there, right? You create an int and you try and put a double into it. So that would be a problem. You get error. I think something about like lossy error or something like that. Like you're going to lose accuracy or whatever. Double, you can put X in. If you cast it to an int first, that should be good. You create an int and you put the int into a double, that's fine. It'll just make it 14.0, but it's not going to lose any of the value. So it's a problem when you try and put a double into an int. So 1 is the only one. What output will be produced by system.out.print? Now, the /n, you guys should all be good with. This is a new line character, right? So definitely, it's going to be on 2 different lines. So definitely not A or B, right? It's got to be C or E because of the new line. Now, usually, a double means that would usually be a comment, right? Actually, a slash with a star is also another way of commenting. But those are inside of the quotation, so it has a different approach there. So these are called, in general, these slash things are called escape sequences. Okay? And in a string, they're called escape sequences. So, that's inside this whole big string. /n is a new line, which we use a lot. /quote is actually how to get a double quote symbol. Double. And then // is a backslash. Now that's if they're inside a string. If you just did a double this, it would be a comment, right? So this is a comment. This is a comment. But if they're not in a string, so you got to be careful. These are all inside of a string. They're all inside these quotations, right? So the slash with the slash just gives you a slash. That's what it prints out. And then the stars are just going to get printed out on their own. Star gets printed out. This // inside is going to give you a single slash. So it's going to be /*/. It's not the double slash. So you just got to understand your escape sequences. Special commands inside of a line that allow you to print different things. Okay. Consider the following code segment. If n is not equal to 0 and x divided by n is greater than 100, do something else, do something else. If n is of type int, okay, so we know it's an int, okay, and has a value of 0, so it's going to be 0, which segment, when the segment is executed, what will happen? The thing you got to watch out for, that they're kind of hoping you notice, is that division by 0 gives you, x over 0 on its own gives you an arithmetic exception. because you can't divide by 0. Okay. And so that's what a lot of people are going to go for. They're going to say, oh, there's going to be arithmetic exception thrown. A syntax error? No, there's no syntax error. Syntax error would be like it wouldn't compile. It compiles, right? There's nothing wrong with it. The issue, it sounds like, is going to be when it runs. And it says this one, statement 1 will happen, but not statement 2. Or statement 2 will happen, but not statement 1. And neither of them will happen. And control will pass to the first statement following the if statement. So they're just saying neither of them are going to be true. Now, this is what most people are thinking is going to happen. But there's this cool thing in Java. It's called short circuit evaluation. Short circuit evaluation. And short circuit evaluation happens with these compound inequalities when the first one is true or false. So like if the first one is false and it doesn't even matter what the next one's going to be because they both have to be true, right? So if we know the first one's false, like why even bother looking at the next one? We're not even going to look at it. And in this case right here, if n equals 0, then this one's going to be false, right? And this one just won't even be evaluated. And the arithmetic exception won't happen. We will actually avoid it. So, and if this whole thing is false, then statement 2 is going to be the thing that happens, not statement 1. So, there's a short circuit evaluation for or. So for and, the first one's false. If the first one's true, then we have to check the other one and see if it's true also. If the first one's false, don't even need to bother. The or one would be if the first one is true, then the next one won't even be evaluated because or only requires one of them to be true. And if the first one's true, it doesn't even matter what's going to happen in the next one. So that would be the shortcut evaluation for an or compound inequality. So something good to know, something that you can take advantage of. Like this code was designed so that the arithmetic set, if they'd switched the order of these, it'd be messed up. You'd get the arithmetic error. Number 4, refer to the following code fragment. You have a double, 13 divided by 5, system.out, 13 divided by 5 equals this answer. The output is 13 divided by 5 is 2.0. Now here's the deal. These are both ints. And so the actual answer is what, 2 3/5, right? But if it's an int, if this is an int and this is an int, then you're going to get an int answer. And it just truncates the answer. The programmer intends it to be 2.6, right? Okay, which of the following replacements for the first line of code will not fix this problem? Okay, so most of them will fix it, except for one. If you cast one of them to a double, then and you divide by an int, you're going to get a double. I mean, that's kind of the big deal here, right? If you divide an integer by a double, that will also give you a double answer. Okay. If you just make the first one a double by making it 13.0, believe it or not, that makes a difference. That works, right? Or that works. All of these are going to work here. This one casts the result to a double, but it's too late because this happens first and you get 2. And then you cast a double and then you have 2.0. This is the one that will not fix it. All the other ones could make it work. Okay. What value is stored in the result? Int result. So it's going to be an integer, and it's going to do all this work here. So you have to understand precedence in Java. It's like order of operations, but it's not exactly the same as PIMDOS. It will do. Let's see. it's going to, sorry. So we're looking for, we're trying to pay attention to precedence, which is like a order of operations, but for Java. And it does multiplication, division, and modulus. They're all considered the same precedence. So they'll just happen left to right. Left to right. And addition and subtraction happen after multiplication, division, and modulus, which kind of makes sense with the order of operations, right? Multiplication, division usually happens before, and modulus is related to division, happens before addition and subtraction. Within these groups, it happens left to right. So in this problem right here, it's going to do this multiplication first, right? And so you're going to get 18. And then it's going to do this division. So, and these are ints. So you're not going to get, you're not going to get, 4.5 or whatever. You're just going to end up getting 4. Because these are all ints right now. It doesn't matter that this is an int. In the middle of it, it's all ints. Then we do the modulus. And 4 modulus 3, the remainder is 1. And then we finally do this subtraction at the end, and we get 12. So you got to understand precedence in Java, and you also have to understand how ints and doubles work. Suppose that addition and subtraction had suppose that they had higher precedence in multiplication and division. Then the expression would give you what? So they're kind of doing a make-believe thing. They're saying, what if addition and subtraction happened before multiplication and division? What would you get? Well, let's just do it. Addition and subtraction left to right. We do that as 5. You would do this right here next, 7 minus 4. Don't do the 4 plus 8. So addition and subtraction happen left to right. Addition doesn't have precedence over subtraction. So that would be 3. And then this would happen. And that would be 9. No, sorry, 11. And then you would do multiplication and division left to right. So you do 5 times 12 is 60. And divided by 11. Now these are all ints. So it's just going to be 5. You're going to lose the remainder of 5 11s. That won't be part of your answer. So the answer is just going to be 5. Which is true of the following Boolean expression given that x is a variable type double. So it's a double. X is a double for sure. Right? X is a double for sure. And this is a Boolean expression because it's saying this is either true or false. It says it'll always be evaluated false. So right now, if you look at this, mathematically, you're thinking, oh, well, x times and divided by x, which is, you just get 3.0. And it's always going to be true. This is what a lot of people would probably just think. Algebraically, yes, but there are some issues in Java that we have to watch out for. Now, here's the deal. These parentheses make a difference. Okay, so what if this is going to happen first for sure? Okay, so one thing that you could expect is that if x is 0, you're going to get an arithmetic exception before you even get to that. So this one gets rid of this one. It could be this, right? It'll evaluate false when x is very large or very close to 0. It may be false for some values of x. So what happens sometimes is that you lose some of the accuracy because there's only so many decimals that Java can hold. And so when you divide this by some maybe long decimal, you lose a little bit of the accuracy on, you don't get you don't get an exact answer for it. So then when you multiply this, you don't get exactly 3. Like it'll be really close to 3, but it might not be exactly 3. So you're going to watch out for that. And so that's the answer. That one's kind of tricky. And okay, so let's see, number 8. Let x be a variable type double that is positive. A program contains Boolean expression math.pow. So this is a way to do exponent. So this would be the same thing as that. It says equals the square root of x. Now, algebraically, we're saying, yeah, sure, that's the same thing. It says that it returned false. It says, which of the following is the most likely reason that it returned false? So for some reason, it didn't work. This says that math.pow returns an integer and math.square root returns a double. That's not true. Math.pow can return a double. And let's see. X is imprecisely calculated in the previous program statement. So they're trying to say X isn't the same or something. The computer stores floating point numbers with 32-bit words. No. There's a round off error in calculating the POW and square root functions. Yeah, so even though we're going to get double answers, this goes back to what we were just talking about in the previous problem. It's not going to necessarily be exact. If it's irrational, then you're going to get some kind of, potential error in the rounding off. And so you're not going to necessarily get the exact same answer from both of them. So let's see, number 9 says, what will the output be for the following poorly formatted program segment if the input value is 22? So they're saying if you put 22, what's it going to be? Now, it says poorly formatted, meaning that maybe it's just hard to read, even though it's syntax-wise, it works. And the major thing I see here right away is that there's a lack of curly braces and a lack of tabbing. Now, the tabbing doesn't technically make a difference, but it makes it easier to read, and that would help possibly. The curly braces are not necessary if there's only a single line inside of them. Now, if you don't put the curly braces, that's how it's going to treat it. So what it's going to do, int num equals, and then this is a comment call to a method that reads an integer. So they're just saying there's like a J option pane or something like that. They get an integer, okay? And we store it. No problems there. And in this case, we're going to give it 22, okay? The input value is 22. So we get in 22. It says if number is greater than 0, which it is, and then it just has another if. Now what happens is this next if is inside of that if automatically, but only that line is. The next one after it isn't. Well, actually, I'm sorry. Yeah. So this is inside of it. Only the next line. If you don't put the curly braces, the next line is the only thing considered as being inside of it, except that this is an if itself, so it has stuff inside. And so this is going to be inside of that if. And then there's an else. So like we could rewrite this in a better way. We could say int num and it equals 22. And then we could say if num is greater than 0, curly brace. And then this one's inside of it. It says if num modulus 5 equals 0. And then the very next line only is going to be what's inside that one. System.out.println num. Okay, and then we close that curly brace. And then this says else here. So this is maybe the confusing part right here, that the next else is going to be considered to be paired with the most recent. I think so. What's going to happen is we only read the next line, right? This was the next line, and this was the next line. And then this would close this curly brace, and this else would be after this. Else system dot out dot println and that message. So let's go back to what we have. We have 22, so this is true. So it goes in here, and 22 modulus 5 is actually 2. So this is false. So this just doesn't happen. And then we come back out here, and we will do this else. Now, if this else was, so this else isn't going to happen because the first if was true. If this was inside here, it would have happened. Which I guess we're going to say is. So I think this one's got to be directly tied to the previous if. So we got to understand some of these like really finer details. If this was outside of this first if, nothing would happen. Nothing will be output. But in this case right here, this is what's going to be output, the message that the num is a negative. So that one's tricky. The curly brace thing is, I think that one's a little more straightforward, but the fact that there's an else right here, it gets tied to the most recent if. So there you go. Let's see. What values are stored in X and Y after execution of the following program segment? So what values of X and Y are are stored in these? So what are the values? So we're starting with X is 30 and Y is 40. It says if X is greater than 0, which the first time is true, right? And it goes down to here. It says if X, which is 30, is less than or equal to 100, which is true, then Y equals X times 30. So that's going to be 30 times 3, which is 90. So the original value of Y is gone at this point. So now it's 90. It says if Y is less than 90, well, that's false. So that's not going to happen. This else isn't going to happen because this true happened. This else isn't going to happen because this true happened. So we're left with X is still 30 and Y is 90. X is 30, Y is 90. So you got to follow these ifs and elses. This one was obviously easier to read than the last one because of all the tabbing and the curly braces. On most of them, this one didn't have a curly brace. So it is common that if there is only going to be one line inside of an if or even a for or a while or an else, that you don't have to put the curly braces. But I think it helps right now. Which of the following will evaluate to true? We want it to be true only if Boolean expressions A, B, C are all false. Which of these will come out true if A, B, C are false? So this is where we have to get good at these compounds and the not symbol. So this one right here is going to be not false. I'm just going to rewrite it with F's for false, T's for true. And this is going to be not false and not false. So we got to work from the inside out. So we got to do this. Now inside here, this is false. And this is true, which I don't think really matters because of that short circuit evaluation. They both have to be true. So this is for sure going to be false. Now, not false is true, and not false is true. And if they're both true, then it is going to be true. Which of the following will evaluate true only if the Boolean expressions. So here's my feeling is I bet all of them are going to come out true. Okay. But some of them would come out true even if one or more of A, B, and C weren't false. So I bet these are all going to come out true, but we're looking for the one that somehow could work without them all being false. So, I mean, if we go through this, it's probably going to, not false, not false, not false. It's going to be true or true or true is going to be true. Now, so this one is going to be not. Which is defined with value true only if all of these are false. I feel like this last one could work. Yeah, so this one, just for instance, like this one, if just one of them was false, just one false, you need just one to be false for one of these to end up being true, for the thing to all be true, because it's an or thing. So while this is true, it doesn't require them to all be false. So that one's for sure out. Can we look at this one and make the same decision? Both of these have to end up becoming true, right? But like I said, the short circuit evaluation, and this is false, didn't matter what this was. So in this one, C could be, and just one of these has to. So I mean, C could be false, or I mean, C could be true, and this would still come out false. It doesn't even matter what C is if this is false. If this was true, and then C would need to be false to come out true. Now, one of these is going to have this one. If B was true, C would also need to be true, but it is possible for this to end up coming out false. We just need one of these to either be false. Yeah, one of these or both of these to be false. So if B is false, then this would still be false. If C was if B was false, it doesn't matter if C is true or false, right? If C was false, this would have to be true. So, anyways, B could be true, and we could make it work out. This one says not. It has all these. So these are all false or false or false. Okay. Which makes it false, which makes it true. Of course, all these are going to come out true. The hard part is trying to figure out, could they come out true with A, B, or C not being false? If one of these is true, if any one of these is true, it's going to come out true, right? Because of all the ors. So I'm thinking this one, they all have to be false, because if one of them's true, all things true, and not true is false. So I'm leaning towards this. I'm going to take a look at the other ones just to make sure. This one looks similar, but false and false and false is going to be not false. It's going to be true right away, of course, but all I need is one of these to be false. And then the whole sign's going to be false because it's a bunch of ands. So that one doesn't require them all to be false, just one of them. And this one would be not false or not false or not false. So this is going to be true. And false or true, that's going to be true. So that's going to be true. And then not true is going to end up being false, but this is still going to come out true because it's an or. And so if the second one came out true, then that would be fine also. So we could change the B and C values and have this come out true, and we'd still get it true. So I mean, if B was true, we'd be fine. if C was true, but B was false. No, if C was true. Yeah, if C was true, then and B was false, so they both be false. It'd come out true. That works. So this one's out. So these are hard. You kind of, I feel like you kind of have to work your way through them. These next couple are very similar style problems. And to me, my best way of doing it is kind of walking it through and figuring out what it says. Assuming that A and B are integers, the Boolean expression will always evaluate to true for what? Always is the key word. Okay. So in this first one right here, if they're equal, it's going to be not. If they're equal, then that's going to be true, right? And A times B. Okay, if they're equal, then that's going to for sure come out to a positive, right? Because even if they're both negative, well, unless there's zero, right? So at first you're like, oh yeah, that's going to work. That's going to be true. Nope, they could be zero, and that would cause a problem. That'd cause it to be false. But here's the big thing. It doesn't even matter what the next thing is. You're gonna get false for sure because the first one's false and it's an and. So this one's for sure just out. It's just not even possible. This one says that A is less than B. So if A is greater than B, if A is greater than B, then this one's gonna be false, right? Okay, which at least tells us that we're gonna get true for the first one. So there's a chance. If A is greater than B, will it always be positive? A could be positive and B could be negative, right? And A would be bigger than B. And if you multiply them together, you get a negative. Greater than zero would be false. And so we would get false. That's a possibility. Like the last one is for sure false. This one could be false, depending on what happens here. I mean, if they're both positive, then we're good, right? If they're both negative, then we're good. But it is possible for one to be positive, one to be negative, and have A bigger than B. So this one's out. It's not going to always be true. A is less than B. Well, the first one is going to be true, right? If A is less than B, and it doesn't even matter what the rest of it is because you know it's going to be false. That one's out. Because the first part's going to end up false for sure. It doesn't even matter. If A is greater than B, so this is like this situation, but this time they're telling you B is positive. The small one's positive. So we know for sure this time that this is false. And so we get true. And since A is bigger than B, and we know B is positive, which means A is positive, which means they can't be zero. So the zero possibility is not, the negative possibility is not there. So that's going to for sure be true, and that's going to be for sure true, and this has to be true. This has to be true. So I'm going with this one. I'm going to take a quick look at the last one. This one's guaranteeing B is negative and A is greater than B. Well, so we know the first one's true. Now, if A is greater than B and you know B is negative, then you're thinking, oh, well, that's going to be negative, that's going to be false, which would not make it work. But if they're both negative, which is possible, you could get it true. So it's not quite known what's going to happen. But it could be false or true. Okay. 13, given that A, B, and C are integers, consider the Boolean expression. So they're for sure integers. Which of the following will guarantee that it's true? It's guaranteed it's going to be true. Well, I'm going to kind of go through this again. Now, be careful. There's quotations around all of this, and then it's not. And it is or. This says that C is less than A. Well, I don't know what's happening for A is less than B then. I just don't know, which is fine. Might work out because if I can for sure make this one true, then but now this is say that this is false. Still doesn't mean anything for the first one. C is less than A is false, which means that C is greater than or equal to A, right? Isn't that what that means? C is greater than or equal to A. So C is equal to A times B. Don't know. Don't know what's going to happen with that because we don't know what it really depends on what B is. And then this says C is less than A. Well, that's for sure true. But still, I'm just like, I don't know what's going to happen. I have don't know. And then not times, let's see. Oh, this says it's false. So we actually know this is false, right? So we know that this whole thing is for sure false, right? Because it's compound. If one's false, it's false. And then not false is true. And so this is actually going to for sure come out true. So I don't know. I'm kind of leaning towards that one, actually. I feel like for sure it's going to come out true. This one says that C is less than A is true. Again, I don't know what's happening in the first one. I still don't know what's happening with C is equal to A times B. This is for sure true now. But I'm still in a situation where I don't know. I don't know what's going to happen here. So I just don't know. We really need information about B. Gotta have. This says that A is less than B is false, which means that A is greater than or equal to B. So it's good to interpret. If they say it's false, then what's true? So if A is greater than or equal to B, then this first one is for sure false, right? But I don't know what's happening with that one again. And this says A is less than B. Well, that doesn't tell me if C is less than A. I still don't know that. So I don't know. It really just depends on what's happening in here. But we don't know. We can't say it for sure. And then this says C equals A times B is true. Well, I don't know what A could be less than B, right? And this still be true, right? 3 times 1/3 times 3, but it could be the other way around. 3 times 1/3 equals, I don't know. So we don't know. And then we know that's true, right? But we still don't know if C is less than A. I mean, they're integers, so there's no way they could be fractions. So if C equals A times B, I mean, if A is positive, yeah, I don't think you can say anything about that. So, and this one's saying that's true and that's true. So this is going to be, we don't know what's happening with the first one. This is for sure true. And this is for sure true. And so this is not false. So it's for sure true. Or, no, it's not true. So this is for sure false. So it really depends on that first one. We don't know. Okay. So I don't know. That's my best bet is working my way through those. I feel like it takes a while. But the more of these you do, the quicker you get. "14. In the following code segment, you may assume that A, B, and N are all of type int. Okay, what will happen if A equals B is false? So A doesn't equal B is what's true. Okay, so let's go up here and see what's happening. A doesn't equal B is true. So that means this is true for sure, right? That's for sure true. And, well, we have to figure out what's going on here. Now, n divided by, these are all ints, right? So you're for sure going to get an int answer. A cannot equal B, so we know we're not going to get division by 0. Okay, so if anything says something like an arithmetic exception or something like that, I don't think that's going to happen, right? But I don't know if we can say if this is true or not. We don't really know what n is compared to A and B to know if it's greater than 90. Like, I don't know. Right? This would happen if A equaled B, we get arithmetic. But it's not going to happen for sure because we know that's false. So but I don't know. Other than that, I don't know if we know what's going to happen. It's going to be one or the other, right? There's not going to be any compile time errors. There's nothing wrong with what's written here. The exception would be the arithmetic exception, and we've ruled out that's not going to happen. So I think it's just got to be one or the other is going to happen. 15. Given that n and count are both of type int, which statement is true about the following code segments? So this is a for loop. It starts at 1, goes less than or equal to n, and count plus plus. System gets prints out the current count. Okay. So like if it started at 1, it'd print out 1, 2, 3, 4, 5, 6, all the way to n because it has the or equals to. So it is going to print out whatever n is. Now the only thing that would change is if n was negative, then nothing would happen. This is like a while loop that looks like it's trying to mimic a for loop, right? So creating a counter before it and doing the same check. So this is the same as that. This is the same as that. System.out. This is the same as that. And then we're incrementing it, which is the same as that. So, I mean, these look exactly the same. 1, 2, 3, 4, 5, 6, all the way to n, right? I think they do the exact same job. 1 and 2 are exactly equivalent. It seems like it. This says that they're exactly equivalent for values where n is greater than or equal to 1, but differ for n is greater than or equal to 0. Well, if n is equal to 0, and you're starting at 1, both of these are going to be false. If n is negative, they're both going to do the same thing. So they're exactly equivalent except for n equals 0. No, they're both going to do the same thing when n equals 0. If n is even, that doesn't matter. Are not equivalent for any values. No, I think they are equivalent all the time. So, all right. The following fragment intends the user will enter a list of positive integers in the keyboard and terminate the list with a sentinel. A sentinel is a special character or special input that signals the end. Now they're saying the sentinel, because it's a constant, they're going to use all capital letters to name it. That's one kind of special thing. And they're saying enter -999. So as soon as that gets entered, it says could process the value. And then this is the value reads in the next user input. Okay. It says the fragment is not correct, which is a true statement. Okay. So essentially, we're trying to figure out what's wrong with it. Can we figure out why it's not correct? This says the Sentinel gets processed. Well, it's only going to process it if it's not the Sentinel. So I don't think the Sentinel is going to get processed. The last non-Sentinel value ended in list fails to get processed. Well, we're not reading value in until after we process the code. So I kind of think, let's see, we don't have the Sentinel yet. Current value is 0, by the way, at the beginning. So this is for sure true the first time. I think what's going to happen is this value of 0 is going to get processed. I think the order of this should be different. We should read a value and then process. Well, but that could cause problems too, because if it ends up being the Sentinel, then we end up processing Sentinel. What I think we have to do is read the value in one time first for this to work. So a lot of times if you're trying to look at how code, what's wrong with the code, you need to start thinking, well, how could I fix it? So I think what's going to happen is the zero is going to get processed first. The last non-sentinel value, I don't think that's true. Poor choice of sentinel will cause the loop to terminate before all values. No, poor choice would be like if you give it a positive integer. Let's see. The code will always process a value that's not in the list. It's always going to process that first value of 0, which shouldn't be a positive integer anyways. Entering the sentinel value as the first value causes runtime error. No. So that's the key right there. This is the way you would fix it. If you can figure out how to fix it, then that means you understand what's wrong with it even better. Okay, 17 says, suppose that base 2 binary numbers and base 6 hexadecimal numbers can be denoted with subscripts as shown below. So hex binary. Binary is base of 2, which is equal to 3D hex. Okay, what's equal to 3D hex? So if you recall, hexadecimal is base 16. So they use 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That would be base 10. That's decimal. But hexadecimal is 16. So what we start doing is start using letters for the next digits. 10, 11, 12, 13, 14, 15. And that's good enough because we started at 0, right? So this would be 16. So it goes all the way up to F. What that means is that, like for instance, like in this case right here, this would be 2A, which would be 10. And the way it works is that this is 2 times, the first one, the 10 is times 16 to the 0, and then the next one is 16 to the 1, and then it keeps going up. More numbers give you more 16s of powers. So that's going to be a 1, and this is the same thing, and that's going to be a 32. So this is the same thing as, that's going to be 10. This is the same thing as 42 as a decimal number, just to make it kind of connect it with you. How would you write 42 in binary? So binary is some number times 2 to a power plus some number times 2 to a power plus some number times 2 to the power, all the way down to 2 to the 0. So these are just kind of empty circles. All right, and then it would be 2 to the first and 2 to the second. All right, so 42, what you do is you try and take the biggest power, 2 raised to the biggest power you can out of 32. So you got 2, 4, 8, 16, 32. And so that's 2 to the first, 2 to the 0, 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, 2 to the fifth. So we're definitely going to have a 2 to the fifth. So 0, 1, 2, 3, 4, 5 is going to be the biggest one. And we just need one of those. Okay. And then there's a 10 left over, right? So what's the biggest power 2 that we can take out of that? Well, that'd be 2 to the third. would give you 8. So the 2 to the third, we're going to have one of those. And then we'd have 2 left. And what's the biggest power 2 is that? That's 2 to the first. So we need one of those. In between, we've got to start at 2 to 0 since we have none of those. We put a 0 there. We have none of these, put a 0 here. We have none of these, put a 0 here. So it's 1, 0, 1, 0, 1, 0, which is what they told us. So that was just good practice. So how do we do it for 3D hex? Well, D is 13, okay? And so this is the equivalent of 3 times 16 to the first plus 13 times 16 to the 0. So that's going to be 48 plus 13 is 13. 16 to 0 is 1. That's going to be 61. So we're trying to get 61 into binary. Now, there's some other tricks of going directly from hex to binary and whatever, but I find myself more comfortable, unless I practice those tricks a ton, I find myself more comfortable, at least right now, changing it to decimal, because that's what I feel really comfortable with, and then changing decimal to binary. So you want to pull out 2 to the biggest power out of this. Now, I already wrote these down. Next one's 64. So it's going to be 32 again. So it's going to be 2 to the fifth. We need one of those. Okay, that's for sure the biggest one. And you don't need anything bigger than that. So we just got to figure out all these other ones. Now, if you take 32 out of this, what's left? 29. So what's the biggest power 2 you can get out of this? Well, that would be 16. 2 to the fourth. So we need one of those. So we take 16. Now we have 13. What's the biggest power 2 that you can take out of 13? 8. So we need one of these. And then you have 5 left. Biggest power is 2 squared. So you need one of those. You take that 4 out, and then you have a 1 left. What's the biggest? How do you get 1 from 2 power? You need this one right here. This is going to be 0, though. We didn't need any of those. So it should be 1, 1, 1, 1, 0, 1. Binary. 1, 1, 1. So 4 ones, and then 0 and 1. So those get better with practice. Okay. Let's see. 18 says a common use of hexadecimal numbers is to specify colors on web pages. Every color is red, green, blue. Component RGB. Decimal notation. These are denoted with an ordered triple. There's 3 colors, where X, Y, and Z are the 3 components, each in the integer from 0 to 255. So each of these numbers, 0 to 250, for example, a certain shade of red whose red, green, blue components are 238, 9, and 63 is represented by this, 238, 9, 63. In hexadecimal, a color is represented with RRGGBB, where RRGGBB are hex values for red, green, blue. Using this notation, the color 238,963 would be coded as EE093F. Which of the following hex codes represents this color? So all we're doing is we're taking decimal numbers and changing them to hexadecimal. So we already kind of practiced that up there. So you want 16 to the biggest power. Now, 16 to the 0 is 1. 16 to the first is 16. 16 squared is 256. So if you look at 14, it can't hold any 16 to the first or 16 squareds. It can only hold ones. So that's going to be 14 times 16 to the 0. So that's going to just be a 14 as hex. This, we can take one of those out. So you're going to get a 1 times 16 to the 0 plus, or 16 to the first. And then what's left? Well, you have 4 times 16 is 0. So this one's going to be, so we got 14. We got 14. And then we have okay, but we have to go back up here. 14 would be E. So this should be E. And And so 0 times 16 to the first, we're not going to ever get 256 because they only go up to 255. So it's got to be a combination of those. So the first one, 16 to the first is 0. And then 14 is E. Okay, so 0E should be ours. And so just with that, it's E. It's one of those guys. It's none of these. And then 20 is going to give you a 1 and a 4, so 14. So this is our answer, even without looking at the last one. Now, 255 is about as big as you can get. How many 16s is that? Well, it's 15 16s, right? Which is an F 16s to the first power. And then you're going to have, what's 15 times 16? I think it's, 30, carry the 3, 8, 0, 6, 1, 0, 14, 240. So then you still have 15 left over times 16 to the 0. So that's another F. So the last one should be FF. So that one is for sure answer C. Now I'm going to stop this video and I'll do a separate video for the remaining problems.